Looking at part C, it says find the derivative with respect to x of x times the natural log of x. Again, we have to do 1 d2 plus 2 d1 is what we're looking for here. So the first function here is x. The derivative of the second function, let me go ahead and label the function so you see what I'm looking at. The derivative of the natural log of x is 1 over x, so that's times 1 over x, plus the second function, which is the natural log of x, times the derivative of the first function. Well, the derivative of x is simply 1. So on this one, I'm getting x over x plus the natural log of x, but x over x is simply just 1. So this would be 1 plus the natural log of x. Let's look at the next example here. Next example is the natural log of x quantity cubed. So the derivative of that, we're going to use the general power rule, drop the power, which would be 3, keep the inside the same, which is the natural log of x, to the power minus 1, which would be a square. But then remember, you have to multiply times the derivative of the inside. The derivative of the inside in this case is the natural log of x. And the derivative of the natural log of x is 1 over x. So putting it all together, it looks like I have a 3 natural log of x quantity squared all over x. 3 times the natural log of x quantity squared all over x. So I'll put that in the answer blank. There we go. Okay, let's look on. These are the properties of logarithms that I needed you to remember. We looked at these in the, I believe it was in the functions review section before class, before we really got into the limits. We looked at the functions review and I reminded you of these properties. And what were the properties? The first one is the natural log of a product can be separated. So multiplication can be separated to addition. Division can be separated to subtraction. And if you have an exponent, you can bring it down in front. So why do we use this? Because this makes derivatives of nasty, nasty functions. As long as you take the logarithm or have a logarithm there, you can get rid of these powers, you can separate products, you can separate quotients, and it really makes for some cool techniques in finding derivatives. So let's take a look at this first one. It says differentiate f of x equals the natural log of the square root of x plus 1. So what I really want to do is look at this as, this is f of x equals the natural log of x plus 1 raised to the 1/2 power. Well, again, because of that rule, what we're able to do is we're able to move that exponent out in front. So this is really f of x equals 1/2 times the natural log of x plus 1. Why would we want to do that? Because now when we find the derivative, we don't have to do a chain rule with a chain rule inside of it. We can just straightforward do a chain rule once. And let's see what I'm talking about here. So let's find the derivative, f prime of x. 1/2 is your constant multiple. The derivative of the natural log of u is 1 over u. So in this case, 1 over x plus 1. And then we have to multiply it times the derivative of u. So that's the derivative of x plus 1. But the derivative of x plus 1 is just a 1. So it looks to me like we have what? 1 over 2 times the quantity x plus 1, or you could have said 1 over 2x plus 2. Totally up to you. I don't care how you write it in that case. Put that in the final answer blank. And let's move on. In fact, what we could do is we could take really, really nasty problems. So this next one is the natural log of x times x squared plus 1 quantity cubed all over the square root of 2x cubed minus 1. This is just a absolutely atrocious, disgusting problem. This would be a chain rule that has a product rule, chain rule with a quotient rule that has a product rule which has a chain rule. And in the other one, you have another chain rule. I mean, it's just a dang mess. But let's see if we can use those logarithmic properties. So what I'm going to do is I'm going to use the fact that this is x times x squared plus 1 quantity cubed. And on bottom, I'm going to look at this square root as it's raised to 1/2 power. But remember, division separates to subtraction. So I'm going to use the fact that multiplication separates to addition and division separates to subtraction. So really what this is it's the natural log of x plus the natural log of x squared plus 1 quantity cubed. And then that's because it's multiplication, you have addition. Then because it's division, you have subtracting the natural log of 2x cubed minus 1 raised to the 1/2 power. So all that's using is multiplication separates to addition and division separates to subtraction. So that's what I've done now, but I can even go further by moving those numbers out in front, those exponents out in front. So the simplest version of this for the original function would be the natural log of x plus 3 times the natural log of x squared plus 1 minus 1/2 times the natural log of 2x cubed minus 1. Now I can find the derivative of 3 separate terms. I don't need to use the product rule, the quotient rule at all. Absolutely beautiful. So this tells me that f prime of x equals, well, the derivative of the natural log of x is 1 over x. The derivative of 3 times the natural log of 1 over x squared would be 3 times 1 over what you see, x squared plus 1. But then we need to multiply that times the derivative of the inside. So we still have to multiply that times the derivative of x squared plus 1. Then we'd have minus 1/2 times the derivative of the natural log of 2x cubed minus 1 would be 1 over what you see, 2x cubed minus 1, times the derivative of what you see, so times the derivative of 2x cubed minus 1. Well, the derivative of x squared plus 1 is simply 2x, and the derivative of 2x cubed minus 1 is 6x squared. Let's do a little bit more simplification. F prime of x here, my first term is 1 over x. My second term, I have the 3 times the 2x, so that would be plus 6x over x squared plus 1. In my last term, I see a 2 on bottom, a 6 on top, so that's going to simplify to be a 3. So I have a minus 3x squared all over 2x cubed minus